Hello, welcome back. I'm sure you enjoyed that break. Now we extracted the files. It's sitting in the desktop folder. So we got to copy that path. So go to LCD, the file. This is the files that's extracted. Go to drivers, CMSys, choose on device, ST micro device, and then STM32F4XX, yes. And include. Okay, so copy this path, Control C, go here, right click, go to properties and include paths. I'll remove that. Include paths. Okay, so now that's included. Apply. Yes. Apply and close. So now you got to go here. Right click. Build the project again. Still showing that as 3 errors. Just give me a sec. I'll fix this. LCD. Go to desktop. LCD. Extracted files. Drivers. CMSys. Then device. ST. Control C. You have to copy this path and go to properties. Click on settings on C build, include paths. Okay, apply. Yes, apply and close. Let's build this again. Build project. Okay, still there. So right click on this, open. Right click, open declaration. Then go down here. We got to copy the declaration files from here. So 411xe. So you got to copy this symbol. And you got to go here, right click, properties. You need to save that in the preprocessor. Settings, preprocessor. Okay. Then apply. Apply and close. Go here, right click and build the project. Still shows us 3 errors. It says a file is missing. core cm4.h, so we need to include that as well. Not there. So we need to go to the folder again, device st, then include no, not this time. Where is it? Include. Going to the folder again, desktop, LCD, drivers, CMSys. Go to include this time. We need to copy this core, that header file. So copy the link, copy, right click, properties, C++ build, settings, include paths, add another path. Okay, apply, operation in progress, yes, apply and close. Now go back and rebuild the project again, build project. Okay, I think we successfully linked all the necessary files that we need. So this is what we've been trying to do for the last few minutes. So it's all linked, so it's all happy. Good. So I will minimize all this so you won't get any confusion. I will close. Yeah, so we are in main. So now let's go and start writing our code. So first we will start to write with declaring macros. Declare. First let's declare the macros. Declare macros. To do that, shift hash define. First you need to do the control files, all the 3 control files. So you got to do that first. So hash define register select first, and as you know, you got to say this. So in binary code, binary, this will be in the register 0, 0, 1, 0 and 0, 0, 0. It is PB5. I'll write it here. This is PB port B pin 5. You're connecting the register select. So likewise, you got to connect the read write and the enable. So I'll copy this and paste it twice and modify it. 0x40 and this will be 0x80 and this will be 1 and this will be 1 and this will be the read select. PB6 is read write pin. PB7 will be the enable pin. PB7 will be the enable pin. Okay, so now we define the macros. Now we got to go and define the prototype, which is all the peripheral clocks on the motor register and output registers. So now define the prototypes. To start off with, let's create a message, unsigned character message of A to Digi. Okay, and then now we got to initialize the GPIO. So initialize GPIO, create a function for this, void GPIO init. So you're going to write the initialization first, so copy that. Okay, so in the initialization, first step, we need to set the peripheral clocks. Set the peripheral clocks for GPIOB, GPIOC, because GPIOB we're going to use the control lines, GPIOC we're going to include the data lines, so that's why we got to enable both of that in one single line. You can do that by writing this command ahb1enr. You just do a simple r with the value, because enabling GPIO B, GPIOC. So that's what this command does. Okay. I will check for errors at this stage just to make sure we are going through the right path. Yeah, don't worry about the warnings because we haven't finished the whole program yet, so that's why the warning is. I'll call the GPIO init in the main program. So save and then do a right click, build the project. Shouldn't show that warning, so previous definition RS redefined. Sorry guys, I did copy but I didn't change it, that's why. Sorry, my bad. Now save and run, you won't get this warnings now because of the register label that I didn't change because I just copied and pasted. So this is another example. When you copy and paste, always go back and check your register name. So that's why you got the two warnings, because it said the register select already defined and redefined again and again with 3 different locations. So it didn't accept the this code, this line. So yeah, it's good to check like that. Otherwise After you finish about 200 lines of program, then when you start to debug, it takes a long time to get that going. I will also use another line, so because we're using 2 lines, character message 1 off. I want to use it, but I will just 16 cross 2 or simply write welcome. So you need to make sure you use only 16 characters, 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15 16. I think it should display that. Okay, so we enable the peripheral clock. So the next step is you have to set up the debugger as well, because we're going to debug. Right click, debug as, debug configuration, choose this STM32 application, then this immediately connects to the lcd.elf. If you're in doubt, click on the search project, go there and connect. So now you have to come here, debugger, make sure the ST link is enabled and the serial wire viewer enable is on, apply, debug. And this will change from one to the other. Yeah, okay. I just want to show you the clock, this value 0 cross 06 in the SFR register, so you will see that it's because you're enabling in a 4-bit. The bit 0 is, that's port A is 0, port B 1, port C 1, port D 0, so 0 double 1 0 is 6 in binary, 0 double 1 0 is 6 in the 4-bit. Right click, debug as STM32. It's connecting to the debug. Make sure my board is connected. Okay, just one sec. Debug. No ST link detected. Okay, it seems there may be an issue. Just one sec. Okay. Okay, right click and debug as STM32 application. Still can't detect. Right click, debug. I'll do a build first and then do a okay. Now right click, debug. Make sure the configurations are set. So I'll go to configuration just to check. lcd.elf debugger, you enable that, yeah, and then click on debug. So now it should connect, but for some reason I think one of my USB ports is playing up. Sorry guys. Right click, debug. Seems to be a loose connection in my USB port. Just change. Something closer so it may detect. Sorry guys, I'm still trying to fix my drive that's not supporting. Just give me a sec. I brought the board closer to the USB port, so let's give another try. Still not happy. Right click, debug. Because of all the hardware connections, that's why there may be some issue with the USB port. I'll just unplug it. Restart the debug session. Oh, come on, please cooperate. Debug configuration. Debugger, make sure that's enabled again. Click on debug. Sorry guys, I'll fix this issue and I'll be back with you shortly.